There's a metal that has destroyed empires, launched thousand-ship armadas, and rewritten the fate of continents. For it, men have crossed oceans they couldn't map, descended into darkness they couldn't escape, and betrayed everything they claimed to love. But here's what haunts me. Everything humanity has ever pulled from the earth, every ring, every crown, every coin that changed hands in back-alley deals, all of it would fit inside a single Olympic swimming pool, 50 meters long, 25 meters wide, 2 meters deep. That's it. That's the sum total of human obsession, distilled into one shimmering cube of yellow metal. And yet, nations still go to war over it. Central banks still hoard it in underground vaults. And somewhere, right now, someone is risking their life a mile underground just to find one more ounce. Why? What is it about this element, atomic number 79, that makes it worth more than life itself? Let me paint you a picture of scale. Since the first human picked up the first golden nugget from a riverbed, probably somewhere in the ancient Near East, around 6,000 years ago, we've extracted roughly 216,000 metric tons of gold from this planet. Stack it all together, and you get that swimming pool. Melt it down, and you'd have a cube about 22 meters on each side. But here's where the story gets strange. Half of all the gold ever mined, over 100,000 tons, was pulled from the Earth after 1950, after atomic bombs, after we'd already walked on the moon in our imaginations. The ancient Egyptians spent 3,000 years accumulating what we now extract in less than a decade. We're not just mining gold anymore, we're devouring it. And then, in the mountains of northeastern China, geologists made a discovery that rewrote the textbooks. Deep in Hunan province, beneath layers of rock older than dinosaurs, they found it. The Wanggu gold deposit. Not a mine, not a vein. A monster. Current estimates suggest over 330 metric tons of gold ore locked in that single location. But the seismic data tells a different story. There might be twice that amount hiding in the depths we haven't reached yet. One deposit. Potentially enough gold to fill a large room, in a world where finding 10 tons makes headlines. So what makes this metal worth the obsession? Why not copper? Why not iron? Why did gold become the universal currency of human ambition? The answer lives in its atoms. Gold doesn't rust. Drop it in the ocean for 1,000 years, and it emerges exactly as it entered. Pristine, untarnished, eternal. While iron becomes dust and silver tarnishes to black, gold remains. It's the only common metal that laughs at time itself. It's soft enough to hammer into sheets 1 atom thick, so thin you could read through it, yet it never loses its integrity. A single ounce can be drawn into a wire 50 miles long. Try that with platinum. Try that with anything else. But beyond the physics lies something deeper, the psychology. Gold catches light like nothing else in nature. That warm solar glow triggers something primal in the human brain. Ancient circuitry that associates this color with sunset, with fire, with life itself. Neurological studies show our pupils actually dilate when we see gold, the same way they do when we see a loved one. We're biologically programmed to want it. And then there's the rarity. Gold makes up about 4 parts per billion of the Earth's crust. To put that in perspective, if you took 1 million random rocks, you'd find traces of gold in maybe 4 of them. It's common enough to find, rare enough to covet, the perfect trap. But the true cost of gold isn't measured in money. It's measured in human hours, in broken backs, in lives spent underground. To extract a single ounce of gold, enough for 1 wedding ring, miners must move an average of 3 tons of rock. 3 tons. That's roughly the weight of 2 cars, displaced, crushed, processed, and left as toxic tailings for every piece of jewelry on your finger. The process is medieval in its brutality and space age in its complexity. First, you find the deposit, often a mile or more underground, in seams that run through solid granite. You blast, you drill. You haul the ore to the surface in elevators that plunge through darkness at terrifying speeds. Then comes the crushing, industrial mills that reduce boulders to powder fine enough to inhale. But the gold isn't free yet. Now you add cyanide, yes, cyanide, which binds to gold particles and separates them from the worthless rock. Then you burn it, refine it, purify it through processes that consume enough energy to power small cities. The final product? A bar of gold so pure, it's 99.99% elemental. 4 nines, the industry standard. The end point of a journey that began deep in the Earth's mantle, where dying stars once scattered their atomic guts into the cosmic void. Because that's where gold comes from, supernovas. Every atom of gold in your possession was forged in the death throes of a star larger than our sun, billions of years before Earth existed. You're wearing stardust, incredibly expensive, incredibly rare stardust. But gold isn't alone in the pantheon of precious metals. Platinum sits above it in price, denser, rarer, harder to extract. The entire global supply of platinum ever mined would fit inside an average living room. It's found in only a handful of locations worldwide, mostly in South Africa and Russia, in deposits formed by ancient asteroid impacts. Then there's rhodium, the king of precious metals. Pound for pound, it can be worth 10 times what gold commands. Why? Rarity beyond rarity. Catalytic converters. Industrial applications that have no substitute. Rhodium is so rare that annual production worldwide wouldn't fill a small closet. And yet, despite their value, these metals don't capture our imagination the way gold does. They don't appear in fairy tales. They don't start wars. They're valuable, but they're not sacred. Gold alone occupies that strange space between commodity and symbol, between metal and myth. But what if I told you that the most valuable substance on Earth isn't a metal at all? Consider helium, that party balloon gas, that squeaky voice novelty. Except it's not a novelty. It's one of the most critical elements for modern civilization, and we're running out. Helium is the only substance that can reach temperatures close to absolute zero, which makes it irreplaceable for MRI machines, for superconducting magnets, for quantum computers. Without helium, modern medicine collapses, advanced physics stops, space exploration ends. And it's finite. Unlike gold, which sits in vaults waiting to be reused, helium escapes. Once released into the atmosphere, it's gone, floated away into space, lost forever. We're using up billions of years of accumulated helium in just decades. The United States maintains a strategic helium reserve, literally a stockpile of this invisible gas, because losing access would be catastrophic. Then there's graphene, a material that sounds like science fiction. Take graphite, the stuff in your pencil, and imagine peeling off a single layer, 1 atom thick. That's graphene. A sheet of pure carbon arranged in a hexagonal lattice that's 200 times stronger than steel, conducts electricity better than copper, and is so thin it's essentially two-dimensional. Scientists discovered it in 2004 using Scotch tape. And it won them the Nobel Prize. Graphene could revolutionize everything. Batteries that charge in seconds, water filters that remove salt from seawater, computer chips smaller and faster than anything silicon can produce. It's not valuable because it's rare. Carbon is everywhere. It's valuable because it's impossible to make at scale, yet. So we return to that swimming pool, that 22-meter cube of accumulated human desire. Gold remains the standard not because it's the rarest, or the strongest, or the most useful. It endures because it's the perfect intersection of beauty, permanence, and scarcity. Because it connects us to our ancestors, who valued it for the same irrational, undeniable reasons we do. But the future belongs to materials we're only beginning to understand, to elements and structures that don't catch the light like gold, but that might power the cities of tomorrow, heal the diseases we can't cure today, or take us to places gold could never reach. The swimming pool might be full, but the story of what we value and why is just beginning. Because in the end, the real treasure isn't what we pull from the earth. It's what we choose to do with it.